We're looking at problem 12, folks, and this is one of our most recent items that we've learned. This is the topic of linearization, and you're going to see why it is linearization in a second. It says the approximate value of y equals the square root of the quantity 4 plus sine x at x equals 0.12 obtained from the tangent to the graph at x equals 0 is which one, right? So the key with this one here is you want to approximate this with a tangent line, which is basically the definition of linearization. Linearization is just approximating a value of a function with a tangent line. And that's the definition of linearization. And that's what all it's asking you to do here. Okay? So we're going to figure this out here. If you remember the equation for linearization, it was our linearization equation was L of x equals, it was f prime of a times the quantity x minus a plus f of a. We derived this in class, and now we basically have to figure out what we're doing here, right? And in this case, it doesn't explicitly tell us that x is a here, but we want to find the tangent line when x is 0. So that's basically, when this says this is telling us our a is going to be 0 over there. So we just plug it in with that knowledge here. Why is a 0 with that one? Why is a not 0 here? Because I want to find the approximate value of this one when x is this one. After I find that tangent line for when x was 0, i.e. when a was 0. So this is telling me here that this a is 0. So we're going to just go ahead and do so right now. So we need to find the derivative, and we're going to plug it in. So I'm going to rewrite this in terms of my function. So L of x equals y prime of, and remember a is 0, so y prime of 0 times x minus 0 plus y of 0, right? So what is y prime of 0? Well, first I got to take the derivative and plug in 0. Let's go ahead and do that now. So we know y is this guy here. I need to rewrite this to differentiate. So it's going to be 4 plus sine of x to the 1/2. Now I'm going to say y prime is, power rule, it's going to be 1/2 times the quantity of 4 plus sine of x to 1/2 minus 1 is negative 1/2 times the derivative of the inside, right? Okay. Now I'm going to simplify this. Y prime is 1/2 times 4 plus sine of x to the negative 1/2 times the derivative of 4 is 0. That's 0 plus derivative of sine is cosine. So that's just times cosine here. I'm going to rewrite this so it's pretty. So y prime equals 1/2. Negative goes on the bottom. It's just, and because it's a 1/2, it's the square root of 4 plus sine of x times cosine of x. Now don't get pretty here, because we want to find out y prime of what? 0. 0. So now that we have y prime, how do we find y prime of 0? You just plug in 0. So this is just like f of x. It's not times 0. It's y prime of 0. So I'm plugging in 0 here. This gives me the square root of 4 plus sine of 0 times the cosine of 0. Okay. Sine of 0, if you remember unit circle, 0 is here, and this is 1, 0. The sine's a y distance, so y distance is 0. So this is 1/2 times 1 over square root of 4 times cosine of 0. The cosine of 0 is 1, so that's times 1. So this is 1/2 times 1 over 1/2. 1/2. The square root of 4 is 2, and that's just 1 over 4. So all of this work just to get y prime of 0. So this we know is 1/4, right? Now, this stays the same. We're almost home free. And now we need to find y of 0. So just plug 0 into this guy, right? So what is y of 0? It is the square root of 4 plus sine of 0. So y of 0 is just the square root of 4, because sine of 0, as we concluded earlier, was 0. And that's just 2 So that goes plus here. So I'm going to rewrite this now. So our linearization that we got when a was 0, i.e. around 0, because they gave it to us there, was 1/4 times x minus 0 is x, right? So it's 1/4 of x plus 2. And this is my equation. Now notice, I have to use this to find this value when x was 0.12. So it's going to be 1/4 times 0.12 plus 2. And I'll gladly use my calculator. So 1/4 is 0.25 times, what was it, 1.2? Oh no, sorry. 0.12 plus 2. And you get 2.03. So this was L of 0.12. Let me write this clear. So this is going to be 2.03, which is clearly listed as choice number B.